Hello everyone. So today we are going to implement this AI driven cars. As you can see here, these cars are driven by through the code. So it's not like exactly they are just moved along a spline. These cars actually use the vehicle movement components. They use acceleration and steering just like a human player, but instead the acceleration amounts and the steering is decided through the code. So yeah, let's see how to implement this system today. So these guys can just continuously go through this track in a given speed continuously. Okay, so I'll select games and vehicle template, and I think I already have a folder name vehicle. Oh no. Okay, vehicles, and I'll name this AI cars. I don't need starter content, so let's create the project. Right, now this is what I have. Let me play. Okay, so it is basically working. So my goal is to make the car automatically drive in this path following a spline. So how can we do that? First, these are splines, but landscape spline actors, so we don't really have a I don't really know a way to get points from this into a blueprint. So let's create a new folder, B blueprints, and let's create an actor class, PP road. Right here, let's add the spline. And by default, let's have 2 points like this. Compile, and where should be the starting point? Let's say here. Yeah, this is also the player's start. So let's put where is it? PP road here. Right, now let me make this road mesh this road. So by the way, if you keep Alt pressed and move one of these spline points, you can duplicate it. Quick tip if you don't already know that. let me disable angle snapping so I can move it freely. I don't need to have an exact map for the spline into this road underneath. Just a rough one would do, but anyway I'll try to make it match as best as possible, as close as possible. Right, so this is the spline and it starts from here and ends from here. Now where is the vehicle blueprint? Here I'll create a child blueprint 𝐴𝐼 and place one here. Right, now open the icon and here I'll add a variable road. This should be from the type pp road. I'll make this instance editable so we can assign this in here. pp road. Okay, now here in the tick, so if I go to the parent of the AI car, you can see user inputs. Where is it? For throttle, and yeah, this move forward is connected to throttle and move right is connected to steering. So here I'll add a custom event accelerate. And we need a float input just like this one. So, and also we need to execute this same code. So therefore let's do something like this. Let's convert this to a macro. Move forward them and duplicate, connect the same thing into accelerate custom event. I'll just call it value, and similarly turn custom event turn. I'll duplicate the same piece of code like this. Now we have these two custom events that we can use to drive the car automatically through the blueprint. So here, how to find, right? So now we need to give these two inputs, turn and accelerate. So to give accelerate, without thinking about turning, let's just make the car move forward. So if I call accelerate here with maybe 0.2 or just say 1, don't know, it should move forward. Now here let me simulate without playing. See, now the car goes forward until it hit the wall. So right now, how can we define a max speed? Let's say 40. So we can get the vehicle movement component for get forward speed. What kind of a value do we get here? Actually we know that because we can find that because if I play the game, you can see in the bottom left the speed the AI car is pushing me. Let me put the player car behind. See, it's goes around 120. Okay, and the calculation is here in vehicle player controller speed. Okay, if mph, we have to multiply by this value. If kmph, this value. So let's consider only kmph, and if I want to keep the speed under, let's say 40, we can say if this is less than 40, apply acceleration. Now the car didn't go that fast, but still it bumps into a wall. To test that, let's make the speed even further. Let me promote this to variable max speed AI speed, otherwise it could be a bit confusing. Let's give 5. So if I'm correct, car should go really slow. It doesn't look like going slow. Why? Let's print what we get here. Oh, it says hello. Oh, sorry. Two. Let's forget about this multiplication and put directly what we get here. Oh, right. So actually, when we have a user input, we always call this if we are not pressing forward button with 0 value. So maybe that's the case. Also, we need to consider the absolute value. So here, instead of having a branch, we can do a selection. If this condition is true, 1, otherwise 0. Okay, it's not moving at all. Let's try 40 with this multiplication. Right, now it's moving. Not that fast. Okay, good. Now we have a car that goes with some control, and the next step is making it turn. And this is also not, I don't want it to be just some following the spline or just moving the car through the code along the spline. That's not the way I want. I want the AI to use the actual vehicle movement component and drive the car. Right, so how can we do that? From the road, in the construction script, oh no, here, let's convert this to a validated get and get spline promote this to a variable road spline. And then compile. Now we should have a reference there in the event graph. So this is regarding acceleration. Let's collapse speed control. Then we need a way to detect steering. So for that, let's have two components here in the car, like sensors, and the mesh, add scene component. These are just reference points. One is here near the left wheel. I'll call it LP, just left point, and another one, duplicate RP, right point on the right side, so that means plus 120. Now we have two reference points from the spline. We have the spline. Let's get location at distance along spline, and I'm going to use the world space. So as the distance, let's promote this to a variable. I'll name it target spline distance. So this variable represents the distance along the spline that the car is trying to reach. And by using these, and these 2 points are defined, I am going to determine whether the car should have a right turn steering or a left steering. Right, let's see how this goes, and we can start from there. Let's promote this to a variable, target point. Now the distance from the target point to the car location, by car location get actor location. If the distance is less than, first we need to calculate distance, is less than, let's say, 500 meters, the branch we need to extend this distance. So let's add another 500 so that we can keep the car moving forward. Get the spline distance, add, let's promote this to a variable. Let's call it check gap. I don't have a better name for that at the moment, and set it as the target distance, new target distance. if the distance is higher than the check gap, this distance, if it is higher than the check gap, we don't have to do anything. One more thing, if this exceeds the maximum length of the spline, we need to reset it back to 0 so that we can make the car continue in a loop. But let's look into that part later. For now, let's just see if the car can continue one round. Now how to determine the distance, the direction, and we can give steer. What's the function name I give? Turn. Shall we name this steer? That seems more appropriate. So how do we determine this value? As the first attempt, let's get the target point and get these 2 points, get world location of both points, and calculate distance to each point. Then if LP is closer to that point, to the target point, we should turn left. If RP is closer, we should turn right. Let's see if that works. I'm not 100% sure, to be honest. If this one is greater than this one, that means RP is closer. Yeah. To a select float based on this +1 -1, maybe not +1, like 0.2. let's try first. Let's try. Before that, let me remove that print. It's overloading the screen. Okay, car is coming and it should turn right. It is turning right, but not enough. Okay, so then let's try .6. So car is sort of shaking in two sides, which we should do something to avoid that. Other than that, it seems it can follow the spline. Let's see. Yeah, it can. And also, right, let's prevent that shake into the sides. Maybe we can prevent it if I consider the difference amount. Let's say if this value is, let's add the multiplier here and select the multiplier based on this difference. If the difference is, let's say, let's promote this to a variable gap difference. $10. So if the difference is less than 10, let's not turn until it goes higher than 10. If it is if it is higher than 10, let's turn. Now it's not shaking. Still not perfect. Alright, maybe, okay, there is a way to prevent this. So let's promote this steering into a variable. Steer amount. Instead of directly setting it, let's do a lerp. Use it like this. Get the steer amount. Initially it will be 0. Lerp to whatever this target amount with the we do have the delta seconds here, so delta seconds multiplied by, I don't know, 40. By the way, I am multiplying with delta seconds to keep this change rate independent from the frame rate. It seems working. Yeah, much smoother than before. but it's still not good. And let's see what happens when it reaches the end. One more thing, well, when it reaches the end, we should do this. Let's collapse this. Set spline distance. If this value is greater than, get the rod spline length. We can do a selection here. If it is greater than, the target spline distance should be 0, otherwise this value. So car would be able to continuously follow. And also maybe here instead of increasing, oh no, not there, here, check gap, this is 500. If I reduce that, I think, not check gap, here check gap here is fine, but for here, instead of check gap, let's introduce a new variable, distance increment gap. Let's say 50. Okay, and here let's try decreasing this a bit. Where is the car? So when you reduce that, it can't get tight corners, but for this map it works fine. Oh, not. No, that's not a good idea. So let me change it back to 0.6. and let's have two cars. Let's wait till they complete one round to check if they can continue in a loop. Yeah, it seems they can continue in a loop without an issue. Alright, so with that I'm going to finish this episode. So yeah, you can see the final demonstration. So here I have slightly increased the car speed to 50 kilometers per hour rather than 40, and this is after going 2 consecutive rounds. Alright, so thanks for watching. As always, project files will be available here for the download in the Patreon page. Link would be in the description below. And if you like to support my work, you can get the membership of the Patreon club. See you in another episode. Goodbye.